In the previous tutorial, /posts/python tutorial file.io/, we learned about file.io. Now let's learn about generators and iterators, tools for processing data lazily without loading everything into memory. Let's break it down. How yield works, let me walk through what happens step by step. When the generator function ends, no more yields, it raises stop iteration. The for loop catches this automatically and stops. Fibonacci generators are perfect for sequences where calculating all values up front would be wasteful. The generator calculates each number on demand. It never stores the entire sequence in memory. If you asked for Fibonacci numbers up to 1 billion, the generator would still use the same tiny amount of memory. Infinite generators can produce values forever. Use next to get values one at a time. You cannot use an infinite generator in a regular for loop without a break. It would run forever. Instead, combine it with Iterators or use a manual break. Generator expressions like list comprehensions, but with parentheses instead of brackets. Generator expressions are useful with functions like sum, max, and min that consume all values. The sum function processes each value from the generator and discards it immediately. No intermediate list is ever created. When you pass a generator expression as the only argument to a function, you can omit the extra parentheses. Generator pipelines. One of the most powerful uses of generators is chaining them into data processing pipelines. Each step processes one item at a time. No intermediate lists are created. Custom iterators. An iterator is any object that implements __iter__, and __next__. Stop iteration tells the for loop to stop. Python raises this automatically when a generator function ends. The problem with iterator classes: you can only iterate once. Iteratools. Powerful iterator utilities. The Iteratools module has tools for efficient iteration. These are all lazy. They produce values one at a time. Chain. Combine multiple iterables unlike 1, 2 plus 3, 4 plus 5, 6. Chain does not create a new list. Functools.partial. Functools.partial creates a new function with some arguments pre-filled. It is not a generator, but it is commonly used with iterators and higher-order functions. This is useful with map, filter, and other functions that take a function as an argument. Memory. List versus generator. Generators use almost no memory compared to lists. The list stores all 1 million values. The generator stores only the expression and its current position. For large data sets, this difference can be the difference between your program working and running out of memory. When to use generators. The rule of thumb: if you only need to iterate through the data once and do not need to know the length or access items by index, use a generator. Common mistakes using a generator: twice. Generators are consumed after one iteration. If you need the values again, convert to a list first, calling len on a generator. Generators do not have a length. You cannot call len on them. If you need the length, use a list or count manually. Real-world example. Processing a CSV file. Here is a practical generator pipeline for processing a large CSV file. This processes millions of rows using almost no memory. Each row flows through the entire pipeline before the next row is read.